Evaluate functions today. We started that a little bit yesterday. Do you remember the definition for a function? A relation in which every element of the domain corresponds to exactly one element of the range. You see it on your sheet?
Yeah, I was reading it.
How about this? How about you take 30 seconds and you read that, study that, and then you try to say it back to your partner. Take 30 seconds, read it.
Every element of the domain corresponds to exactly one
10 more seconds.
corresponds to exactly one element of the range. Diego, what's a function? Alright, bud.
And stop, okay?
Good job.
Decide between you and your partner who's got longer hair, who has shorter hair.
Longer, maybe. Ooh, this is long.
Okay, person with shorter hair, you gotta say it first. Person with shorter hair, you gotta say it first. Ready, set, go.
A
relationship in which every element of the domain corresponds to exactly one element. Yes. A relationship in which every domain.
Oh wait, no.
All right, together. A relation in which every element of the domain corresponds to exactly one element of the range. Now, don't go using your own vocabulary in here, okay? I get people when they get to the test, they're like, I don't care what Gent says. This ain't English class. I'm not writing words down. I'm going to say my own thing. So they write down a graph where all the x's go to all the y's. Okay, that'll be a very common response I get, okay? Sounds somewhat legit, doesn't it?
Yeah.
But it's absolutely incorrect. Think about what that person just said. They said all the x's, so let's say you have 1, 2, and 3, goes to all the y's, 4, 5, and 6. Is that, my friends, a function?
No.
If all the x's go to all the y's? Absolutely not. They're totally wrong. And for that, I award them 0 points. Don't get 0 points, folks. Get at least a few. State the definition correctly like I told you to, okay? So, all right. Let's evaluate this function. F of 4, f of 1/4, f of 3x, and f of 5 over x. Okay? First one's nice and easy. We plug in 4 and we get 1/4. But what if you plug in 1/4? 1 over 1/4. What is 1 over 1/4?
4.
Why, Alex?
Because it's a quarter, 0.25. That goes into it 4 times.
Oh, okay, that's a nice way to think of it.
That's actually insane. I think.
Yeah, he might be the smartest person on the planet.
I didn't even hear.
So I'm going to take 1 and I'm going to divide it by 1/4. And instead of divided by the fraction, I can multiply by the reciprocal. And notice how you get 4 over 1 or 4. Okay? Or as Alex said, if you take 1 and a quarter goes into 1 4 times. Okay? The next one, I plug in 3x, I get 1 over 3x. That's nice and easy. But this next one, I have 1 over 5 over x. How do I do 1 over 5 over x? The top fraction is 1 over 1.
You multiply it by the reciprocal of 5 over x or 6.
Of x over 5. And so we get x over 5.
Gracias.
Okay? What I would like you to do, we're going to step up the level of difficulty a little bit. I'm sorry I forgot some of the notation here. F of x is equal to x over x minus 4. On your own, see if you can evaluate f of 4, f of a fourth, f of 3x, and f of 5 over x. See if you can do those. Go ahead.
Uh-oh. I'll just leave it blank.
Okay.
Give me another 30 seconds and we'll go over them together. Sophie, how's Gavin doing?
I think he's okay.
If you ever talk to him, encourage him to send me an email and update me. I'd love to hear a little bit more. All right, 4 divided by 0 is undefined. Okay, that is not 0, it's undefined. Okay, if 0 is on the bottom, it's an undefined result. The next one, I have a complex fraction. I need to figure out what 1/4 minus 4 is. So I'm going to find common denominators. What is 4 written as a fraction with fourths? 16 fourths. And 1/4 minus 16 fourths is negative 15 fourths. So you have 4 over 1 divided by negative 15 over 4. Instead, we multiply by the reciprocal, which is...
Should we defeat 1/4 on the top?
Whoop, sorry about that. I was like, this is not working out the way that it should. Okay, thank you. 1/4 should be on top. So I get 1 over 4, and I'm going to multiply that by 4 over negative 15. Notice how the 4's cancel. I get negative 1/15. Okay, f of 3x, you just plug in the 3x. Man, wow, made all sorts of mistakes today. So you get 3x over 3x minus 4. And then the last one, you get 5x, or 5 over x, over 5 over x minus 4. And notice in this situation, again, you have a complex fraction. We must find common denominators, so I'll multiply top and bottom by x. And when you multiply top and bottom by x, we get 5 over x over, that would be a 5 minus 4x over x. Now at this point, we can multiply by the reciprocal. The x's cancel, and we get 5 over 5 minus 4x. And that's the result. That was a little bit more complicated. Any question there? Going once, twice, 3 times. Flip it over to the other side. We're going to take something that looks super complicated. We're going to make it really easy. We'd also like to evaluate these kind of functions. These are called piecewise functions. Piecewise. Piecewise functions are broken into pieces. Okay? And the first one says f of x is equal to these two things, 2x minus 1 and negative 1/2 x squared minus 3/2 x. It asks us to evaluate f of negative 3, f of 0, and f of 2. What do you think? Do you think that if I'm evaluating f of negative 3, do you think I plug in negative 3 into the top, into the bottom, or into both of them? Which is it? Top, both, or bottom? Why'd you say top?
Because it says x is less than 0.
Ooh, look at the condition here. You'd use the 2x minus 1 if x is less than 0. And what do you notice about negative 3? It is. So therefore, we plug it into the top, and it reads 2 times negative 3 minus 1. And I get negative 7. Do I plug in 0 into the top or bottom? I plug it into the bottom. Notice how they both have x terms, so I just get 0. And then because 2 is greater than or equal to 0, I plug in 2 to the bottom. 2 squared is 4 times negative 1/2 is negative 2. 2 times 3/2 is going to be 2, so it's 3, excuse me, so it's minus 3. And I get negative 5. Any questions on why I plugged those in where I did?
I'm just making sure it's because it's less than 0 or equal to or greater, or sorry, greater than 0 or less than or equal to 0, right?
Yep. I use these as my conditions for where I plug them in.
Yeah, okay.
So you try the next one on your own. Try f of negative 3, try f of 0, and try f of 2. Any questions on those three? Notice that the middle one is always 18, so there's nowhere to plug it in for x. You just always get a value of 18 anytime x is between -1 and 2. Okay, then we get to kind of the meat of this lesson, and this is the important piece that we want to be able to do. This is the new part. This is the part that's going to be a little bit more confusing, and we spent kind of 2 days on this. So today we're going to show you 3 examples. We're going to give you time to work. Tomorrow you get 2 examples, and then you get the rest of the hour to work on the assignment because you need it, because it's a little bit of work. It's a little bit of effort. So this is the piece you're going to have to practice. Some people walk on the test not knowing how to do this, and they pay for it, but you guys are super smart, and you're super responsible, so you're going to learn how to do it. We want to be able to evaluate f of a plus h minus f of a all over h. You're going to use this in calculus. For those of you who are seniors, you go off to college next year, and if you do take calculus, the passing rate in college calculus for freshmen is 70%. That means 30% of people fail, okay? You don't get credit for the course, you don't pass it. You want to know how to do this for calculus. Those who have it with me, you're going to see it again, and we'll make good use of it. So what do? We make a little bit of an organizer. First, I'm going to determine f of a, and then f of a plus h. I'm just going to write those out. F of a is equal to simply a squared. And f of a plus h, that just means I plug in a plus h for the x. And so I get a plus h quantity squared. Now, I know that that seems pretty straightforward, but are there any questions? Because that's actually the spot that most people mess up on. Okay, so we're going to take the f of a plus h, which is that. So I've got a plus h quantity squared. And then I'm going to subtract f of a. So I'm going to subtract a squared, all divided by h. That's the expression we'd like to simplify. There's a couple ways in which you know that it is simplified. First of all, if everything that doesn't have an h cancels, and then the h gets divided out of the denominator. Watch for it to happen. What do you get if you take a plus h times a plus h?
A squared plus ah plus h squared.
A squared plus 2ah plus h squared minus a squared all over h. So if we FOIL out the a plus h, we get a squared plus 2ah plus h squared. What do you notice happens in the numerator? Yeah, the a squareds cancel. I told you this will happen every time. If it does not have an h to it, it must cancel. If it doesn't, you did something wrong. Okay? Something was wrong then. What do you notice about everything that's left in the numerator? It has. So what could I do to reduce this? I could factor an h out of the top to get 2a plus h, and then it's all divided by h. Notice how the h's divide off, and we get 2a plus h. That is when you know you're done. We'll do the same thing here. Even though the function is named g, I'm just going to use the letter f. F of a plus h. So f of a is easy. I just simply plug in a for x, and I get 2a minus 3. And if you plug in the a plus h, 2 times the quantity a plus h minus 3. My rule says that I take this, 2 times a plus h minus 3, and I subtract that. So I subtract 2a minus 3. And that is all divided by h. As I distribute, notice how I have parentheses around here, so I remember to distribute the negative. 2a 2h minus 3 minus 2a plus 3 over h. What disappears? Yep, the 2a's are gone. Negative 3 and positive 3 are gone. And 2h over 2, or 2h over h is just 2.
The answer's 2.
The last example, a little bit more involved. We'll finish with this one today. We won't do the next one. We have f of a and f of a plus h. F of a, we plug in a, I get 5a minus a squared. And for a plus h, I get 5 times the quantity, a plus h, minus a plus h, quantity squared. So I'm going to take that. Minus that, and it all sits over h. Can you see that this is going to get a little bit messy? And I know that it looks messy. Trust me, this isn't that bad. Gave calculus a problem as a challenge problem on their homework. When I write out the solution set, it takes up all 5 dry erase boards. Okay? So I know that this looks lengthy. We could fit this in a small space. There's plenty of these problems that we could literally use more whiteboards in order to try to finish it off. Like, it gets rather ridiculous. So let's try to work this through. 5a plus 5h. That's easy, but what about the next part? How am I going to do that? What's my approach? Do I distribute the negative first, or do I square it first? Square it first because exponents come first. So if we square it, we get a squared, and then we distribute the negative a squared. What's going to be in the middle? Minus 2ah. And on the end of a minus h squared. Minus 5a. And plus a squared. All divided by h. And it holds true every time. That's kind of the neat thing about this, is that if it doesn't have an h, it should cancel. The positive 5a and the negative 5a reduce. The negative a squared and the positive a squared reduce. Every term that's left has an h. If you divide it out, we get a positive 5, a minus 2a, and a minus h. And that is our result. Every time it should work out like that. So let me explain to you what you can start working on, okay? As you look at your homework, you see this page here that says evaluating functions. Okay, so on the front side, you're doing just like we did in our notes, where you're plugging in values, determining the output. Some of them are polynomials, some of them are rational expressions. As you flip it over to the next side, notice that you have some piecewise functions. Those should go pretty quick. Like, you should be able to knock that out in just a couple minutes. And then after that, problems 9, 10, 11, and 12, those are like the problems that we just did. Those f of a plus h minus f of a over h. Now, for those of you who are gone tomorrow we'll be moving on to the next piece, which is exactly like we just did. The only difference is that tomorrow I'm going to open class. I'm going to show you how to do a fraction, and I'm going to show you how to do a radical. Those are 2 things I'll teach you tomorrow, and then you'll have the rest of the time to work. So if you are gone tomorrow, you actually know how to do a fair amount of it, and I'll post the video right at the end of the day. Okay.